Download this code from codegive.com, link in the description below. Thread-safe singleton class in Java, a detailed tutorial for interview preparation. The singleton pattern is a creational design pattern that restricts the instantiation of a class to only one instance. This is useful when exactly one object is needed to coordinate actions across the system. However, implementing a thread-safe singleton in Java requires careful consideration to avoid issues like multiple instances being created in a multi-threaded environment. This tutorial will cover 1. What is a singleton pattern? 2. Why thread safety matters in singleton implementation. 3 different approaches to implement thread-safe singleton. Eager initialization, simple but not always ideal. Static block initialization. Lazy initialization, double-checked locking, with considerations. Bill-Pew singleton, initialization on-demand holder idiom. Using enum for thread-safe singleton, recommended approach. 4. Choosing the right implementation. 5. Potential interview questions and how to answer them. 6. Code examples with explanations. 1. What is a singleton pattern? The singleton pattern is a design pattern that ensures a class has only one instance and provides a global point of access to that instance. It restricts the instantiation of a class to a single object. This pattern is useful in scenarios where you want to control access to a shared resource, such as a database connection pool, a configuration manager, or a logger. Key characteristics of a singleton private constructor the constructor of the singleton class is declared private to prevent direct instantiation from outside the class. Static instance variable a static variable of the class type holds the single instance of the class. Static get instance method a static method, typically named getInstance, provides a global access point to the single instance. This method is responsible for creating the instance if it doesn't already exist and returning it. 2. Why thread safety matters in singleton implementation. In a multi-threaded environment, multiple threads might try to access the getInstance method simultaneously. Without proper synchronization, this can lead to the creation of multiple instances of the singleton class, violating the fundamental principle of the pattern. Imagine this scenario. One thread A calls getInstance. It checks if the instance is null. It is null. 2. Thread B calls getInstance, at almost the exact same time. It also checks if the instance is null. It is also null for thread B. 3. Thread A proceeds to create a new instance. 4. Thread B also proceeds to create a new instance. Now you have two instances of the singleton, which defeats the purpose of the pattern. Thread safety ensures that only one instance is created, even in a highly concurrent environment. 3 different approaches to implement thread-safe singleton. Here are several ways to implement a thread-safe singleton in Java, each with its own pros and cons. A. Eager initialization, simple but not always ideal. Pros simple to implement. Thread safe by default because the instance is created during class loading, which is inherently thread safe. No synchronization is required. Cons the instance is created even if it's not needed. This can lead to wasted resources, especially if the instance is resource intensive. This is a violation of the lazy initialization principle. If the constructor of the singleton throws an exception, it will be thrown during class loading, which might be difficult to handle. B. Static block initialization. Pros similar to eager initialization but allows for exception handling during instance creation. Asterisk thread safe because the static block is executed only once during class loading. Asterisk cons asterisk. Asterisk still suffers from the same drawback as eager initialization, the instance is created regardless of whether it's needed. C. Lazy initialization, double-checked locking, with considerations. Asterisk explanation asterisk. Asterisk volatile keyword asterisk. The volatile keyword is crucial here. It ensures that multiple threads correctly handle the instance variable when it is being initialized. Without volatile, there's a potential race condition where a thread might see a partially constructed instance. Volatile guarantees that the write to the instance variable is atomic, happens all at once, and that all threads will see the most up-to-date value. Asterisk double-checked locking asterisk. The outer if instance equals null check avoids entering the synchronized block if the instance has already been created. This improves performance because synchronization is an expensive operation. The inner if instance equals null check inside the synchronized block is necessary to prevent multiple threads from creating instances if they both pass the first check simultaneously before one of them acquires the lock. Asterisk synchronization asterisk. The synchronized block ensures that only one thread can create the instance at a time. It uses the lazy singleton class object as the lock. Asterisk reflection protection asterisk. The constructor includes a check to prevent instantiation via reflection. This adds an extra layer of protection against creating multiple instances. Asterisk pros asterisk. Asterisk lazy initialization, the instance is only created when it's first needed. Asterisk potentially better performance than a fully synchronized get instance method because synchronization is only used when necessary. Asterisk cons asterisk. Asterisk more complex to implement correctly, especially the need for volatile. Without it, the implementation is broken and can lead to subtle bugs. Asterisk historically, double-checked locking had issues with some older Java memory models, although these are largely resolved in modern JVMs, Java 5 and later. However, understanding the underlying memory model issues helps in understanding why volatile is essential. D. Bill-Pugh Singleton, initialization on-demand holder idiom. Asterisk explanation asterisk. Asterisk the Singleton instance is created inside a static inner class called Singleton helper. Asterisk the Singleton helper class is not loaded until the getInstance method is called for the first time. Asterisk since class loading is inherently thread safe in Java, this approach guarantees that only one instance is created, and it's done lazily. Asterisk pros asterisk. Asterisk thread safe without explicit synchronization. Asterisk lazy initialization. Asterisk simple and elegant implementation. Generally considered the best approach for lazy loaded singletons, prior to the introduction of enums. Asterisk reflection protection, the constructor includes a check to prevent instantiation via reflection. This adds an extra layer of protection against creating multiple instances. Asterisk cons asterisk. Asterisk slightly more verbose than the enum approach. Using enum for thread-safe singleton, recommended approach. Asterisk explanation asterisk. Asterisk enums in Java are inherently thread-safe and guarantee only one instance. Asterisk the instance is the single instance of the enum. Asterisk pros asterisk. Asterisk the simplest and most concise way to implement a thread-safe singleton. Asterisk guaranteed thread safety by the Java language specification. Asterisk automatically handles serialization safely, which can be a problem with other singleton implementations. Asterisk prevents instantiation through reflection. Asterisk cons asterisk. Asterisk not lazy loaded. The instance is created when the enum singleton class is loaded. However, This is generally a minor concern. Asterisk enums cannot be subclassed. If you need to extend the functionality of the singleton class through inheritance, this approach won't work. Asterisk can be less readable for developers unfamiliar with using enums for singleton implementation. For choosing the right implementation, here's a summary of when to use each approach. Asterisk enum singleton, recommended. Use this for the vast majority of cases where you need a thread-safe singleton. It's simple, concise, and handles thread safety and serialization automatically. Asterisk bilpu singleton asterisk if you absolutely need lazy loading and cannot use enums, example due to inheritance requirements, this is a good choice. Asterisk eager initialization asterisk if you don't care about lazy loading and the instantiation cost is minimal, this is the simplest approach. Asterisk static block initialization asterisk use this only if you need to handle exceptions during the initialization of the singleton. Asterisk lazy initialization, double-check locking avoid this unless you have a very specific reason and a thorough understanding of Java memory models and the importance of the volatile keyword. It's more complex and prone to errors. 5 potential interview questions and how to answer them. Here are some common interview questions about singleton and thread safety, along with suggested answers. Asterisk Q, what is the singleton design pattern? Asterisk A asterisk the singleton pattern is a creational design pattern that restricts the instantiation of a class to only one instance and provides a global point of access to that instance. It's used when you want to control access to a shared resource. Asterisk Q, why is thread safety important when implementing a singleton? Asterisk A asterisk in a multi-threaded environment, multiple threads might try to create the singleton instance simultaneously. Without proper synchronization, this can lead to multiple instances being created, violating the singleton principle. Asterisk Q, how can you implement a thread-safe singleton in Java? Asterisk A asterisk, provides several options, explaining the pros and cons of each. Asterisk enum singleton asterisk the simplest and recommended approach. Enums are inherently thread safe. Asterisk bilpu singleton, initialization on demand holder idiom a good option for lazy loading and thread safety without explicit synchronization. Asterisk eager initialization asterisk thread safe by default but not lazy loaded. Asterisk double check locking asterisk more complex but allows for lazy loading. Requires careful use of the volatile keyword. Asterisk Q, what is the difference between eager initialization and lazy initialization in a singleton? Asterisk A asterisk eager initialization creates the singleton instance when the class is loaded, regardless of whether it's actually needed. Lazy initialization creates the instance only when the getInstance method is called for the first time. Asterisk Q, what is the purpose of the volatile keyword in the double-check locking singleton implementation? Asterisk A asterisk the volatile keyword ensures that the instance variable is properly synchronized between threads. Without volatile, a thread might see a partially constructed instance, leading to errors. It prevents instruction reordering by the JVM and ensures that the write to instance is atomic and visible to all threads immediately. Asterisk Q, how does the bilpu singleton achieve thread safety and lazy loading? Asterisk A asterisk the singleton instance is created inside a static inner class. The inner class is not loaded until the getInstance method is called, which provides lazy loading. Class loading is inherently thread safe in Java, ensuring that only one instance is created. Asterisk Q, why is the enum approach generally preferred for implementing singletons in Java? Asterisk A asterisk it's the simplest and most concise way to implement a thread-safe singleton. It's guaranteed to be thread-safe by the Java language specification, handles serialization safely, and prevents instantiation through reflection. Asterisk Q, How can you prevent the creation of multiple singleton instances using reflection? *A** You can add a check in the singletons constructor to throw an exception if an instance already exists. This prevents reflection from creating a new instance by throwing an illegal state exception. All the lazy loading implementation example code showed the prevention method. *Q. How does the singleton pattern impact testability? *A** Singletons can make testing more difficult because they introduce global state and dependencies. It can be hard to isolate units of code for testing when they rely on a single, shared instance. Consider using dependency injection or breaking up large singletons into smaller, testable components. 6 code examples with explanations, combined. Here's a combined code example showcasing all the discussed singleton implementations. This tutorial provides a comprehensive understanding of the singleton pattern, thread safety concerns, and various implementation approaches. By studying these examples and understanding the explanations, you'll be well prepared to answer interview questions about singleton and thread safety in Java. Remember to focus on the trade-offs of each approach and be able to justify your choice based on the specific requirements of a given scenario. Good luck.